Hey folks, how's it going? This is Mr. Murray coming to you with a video for Course 1 Honors. This is a due now video for March 30th, 2020. So the problem here is we need to solve or simplify, all right? Because this is what's been going on. Let's take a look at this recap here, okay? So we started off the closure by really trying to tighten up our skills on factoring and kind of developing those skills. We move forward to try to solving equations by using factoring. All right. And then, as we talked about in the Hangouts, etc., there's another method that we can take towards solving. And so if you haven't seen it, I recommend you check out the Hangout that's for last Friday. Because in that Hangout, we started to look at situations where there were no solutions to equations at all. And we took a look at how roots factor into that. All right. So here's what I want you to do. I want you to take a moment. I want you to try to solve the first equation, finding all values of x. I'll tell you right now, there's either going to be one or two solutions. Then I want you to try to simplify completely the two roots you see below. Okay, and when I say simplify completely, in your final answer, the root should not be able to be broken down any further. All right, so take a moment, pause the video, solve the first, simplify the second and the third, and then when you're ready, unpause, and we'll see that if you were right. All right, so here we go. Let's start with the solving. So here, I'm going to first need to remember that I need to make the right-hand side equal to 0. Okay, that's essential because eventually we're going to see in factored form, we're going to have two things being multiplied. And so when we multiply two things together, we want them to be equal to 0 because that's the easiest situation to solve. Now I notice a is more than 1, and particularly it's a number that if I was going to box out, it would be very difficult to box this. So what I'm going to do is I'm going to see if there's a greatest common factor. So I notice that 8 and 1 add up to 9. So 18, this number is divisible by 3. 5 plus 1 is 6. So the 6 is a multiple of 3. So since the digits add up to a multiple of 3, this number is also divisible by 3, and hopefully you can see that 30 is 3 times 10, so 30 is also divisible by 3. So you have two options. One, only because it's an equation, you can divide everything by 3. I'd like us to get in the habit of doing this and factoring out the 3, because when we talk about factoring, I don't want people to divide and forget that you can't do that when the problem is just to factor and not to solve. So I've got 6x squared. Now, 3 goes into 5 one time with a remainder of 2. 3 goes into 21 17 times, or rather 7 times, so it's 17. And then I've got a 10. I'll check through again, but you might know that 17 is a prime number. So for that reason alone, because neither of these are clearly a multiple of 17, there's not any more GCF that we can take out. Okay? Because also remember, another reason I do this is because remember, when I say to factor completely, neither of the factors can have a GCF. All GCFs must be taken out. And if it's something you're struggling with, that's okay, because it's likely that we're going to cover factoring again next year, but it's good to have a jump on this stuff. Okay, so now I need to factor this out. So 6 is going to break down into 1 and 6 or 2 and 3. And 10 is going to break down into 10 and 1 or 2 and 5. So not bad. I know that both numbers need to be positive because it's either two positives or two negatives. We'll multiply to a positive, but they have to add to a positive as well. So I need both numbers, that is the number above here and the number above here, to both be positive. Okay, so this is going to be challenging, and it's something we might not be able to do. So I'm going to try this. Let's let this be 6 and this be 1. And let's see if I can make 17. Well, if this is 5, I get 30. I'm way over. But what if it's 2? And I make this a 5. Then this would become a 5x. This would become a 12x, right? Because 5 times x is 5x. 6x times 2 is 12x. And perfect, it adds up. So the final factored form is that we have it looking like this. We have 3, we have 6x plus 5, we have x plus 2. Okay, and you can verify if we distributed, we'd get 6x squared plus 12x plus 5x for a total of 17x plus 10. All right, so now we go about solving. So again, we have a number 3 times a number 6x plus 5 times a number x plus 2. They all multiply to be 0. So we know that one of them, or multiple if possible at the same time, has got to be 0. We know that 3 isn't 0, so we don't have to worry about that. So what would make 6x plus 5 equal to 0? So one way to do it is you could do it in your head, and if you do it in your head, at this point, I'm okay with you doing work in your head, keeping in mind that you're going to lose credit if it's wrong. So maybe you know that you're going to have to subtract 5 and then divide by 6 to get x alone. But again, it just comes down to, can you solve a two-step equation? We can do that. Here I can see that the answer has to be -2. So my two solutions are -5, 6 and -2. Now, if you forgot to remove the GCF and somehow you were able to factor this, then what would happen is you would still get the same two answers, but maybe instead of getting 5/6, you would get, I don't know, maybe 15/18, and you'd have to simplify that to 5/6, right? Or, right, because if this, let's say you'd not taken it out and you would have gotten like 18 and 15, right? You can imagine that there was a 3 common factor you had to remove, etc. Okay, so those are my two solutions, -2 and -5/6. And you could verify that those will actually make the equation true. Okay, moving down, we have 288 square root. So remember, the trick to this is I need a perfect square that's a factor of this. So many of you might have seen that 88 is a multiple of 4. So therefore, 4 is a factor. So I could do it like that. Let's try it that way. So I would do 288 on my calculator divided by 4. You'd probably have a calculator for this type of problem. And I would get 72. So because 4 times 72 equals 288, the square root of 4 times the square root of 72 equals the square root of 288. And we know that the square root of 4 is 2, and the 72 we leave as a 72. Now, as I said, kind of in getting the problem started, you do have to make sure that 72 cannot be further broken down. And the problem is that 72, well, you might know that 72 is 9 times 8. That is true. Okay, so I do the square root of 9 and the square root of 8. So I get 2 times the square root of 9, which is 3, and the square root of 8, I leave it. And so what I get is 6 root 8, because these multiply, and the 8, you never multiply into the root. You only multiply a whole number by a whole number. You cannot distribute the 2 into the root. It doesn't work like that. Also, if you do that, you're distributing twice. First of all, you can't distribute directly into a root. And second of all, you're only distributing one time because there's only one thing that you're distributing to. Okay, so now we'd have to check again. And actually, as it turns out, 8 breaks down into 4 and 2. So that means that you have to do it one more time. So you'd get 6, and the square root of 4 is 2. So you'd get 12 root 2. And now you would be done. But see, the issue is because I didn't pick the biggest perfect square, and there was actually 2 times I didn't do that. So first, here I didn't pick the biggest perfect square, and that required me to take additional steps. And then here I didn't pick the biggest perfect square, so it required that one last step. For example, 72, I'm sure there's a number that's bigger than 72 that goes in there that we could probably figure out. For example, I believe 36 goes into 72, etc. So as it turns out, if you do 288, 288 is 144 times 2. And you can kind of see that based on the answer. So by picking the biggest square root, you just jump directly to 12 square root 2. So the moral of the story is, if you pick the smallest root, if you want to break it down slowly and choose 4, and then choose 9 and choose those nice small roots, that's perfectly okay. You will get to the right answer, but you have to remember after every single step, you have to check what's left in the root. So here I know every perfect square is bigger than 2, so I'm done, right? So if you don't, again, choose the biggest perfect square in the very beginning, you may have to continue to break it down over and over. So you have to be really vigilant and continue to check the number after each step. And only when there are no perfect squares that will go into that number in the root can you say that you're done. All right, proceeding to the last problem. This is one similar to what we did in the Hangout. So 108, again, is divisible by 4. So let's list out the perfect squares. We've got 4, we've got 9, we've got 16, we've got 25, we've got 36, we've got 49, we've got 64, and let's just do 81 because 100 definitely does not go into 108. Hopefully you can see that. So again, it ends in a 0, 8, and that's a multiple of 4. So 4 actually will work. The digits 1 plus 0 plus 8, they add up to 9. So 9 actually will work because if the digits add up to a multiple of 9, the number is divisible by 9. 16 does not go into it because you got 16, 32, 48, 64, 80, 96. And already at 96, you can see if I add another 16, I'm going to shoot way above 108. 25, notice the last two digits aren't a multiple of 25, right? So that's not going to work. 36, so you have 36, as we just saw from the previous example, 72. And then I believe 108 would be the next one. So 36 works. 49 is not going to work. 64 is not going to work. And 81 is not going to work. So what I should do is I should plug in 36 first. And so if I rock with 36, I've got 36 and 3 because 36 times 3 is 108. The square root of 36 times the square root of 3 is equal to the square root of 108. So what I get is I keep the 5, I open my parentheses, I drop the square root of 36, which is simplifying to 6. That's the whole point. One of the numbers needs to become a whole number. And then I drop my root 3. And then the last step is you do have to do the distribution. So you get 30 root 3. And that is your final answer. Okay, now I'll show you another example. What if I had chosen 9? So if I did choose 9, if I had that intuition, so if I had chosen 9 from the beginning, well, 9 times 12 is 108. So you would have started with 5 times the square root of 9, which is 3, times the square root of 12. So you'd have 15 root 12. But then you'd have to break down root 12. So 12 is 4 and 3. So you get 15 times 2 root 3. You distribute again. And you'd get 30 root 3. Okay? So either way, you do get the right answer. All right, so hopefully you found this video to be helpful. I really do hope that everyone got all 3 answers correct. If so, really great job. If not, if it was the factoring one that's a problem, I would recommend going back rather than solving. Go back and take a look at early last week. If it was the roots, go back and take a look at later last week, including the Google Hangout. All right, but keep up the good work. I've got a really great lesson today that I hope you enjoy. And remember, you can do it. All right, thanks again for watching. Feel free to like or subscribe to stay up to date with my latest videos. Don't forget to love math, and have a wonderful day.